Hey everybody, it's Lon.TV, and we've got a special today because my friend Matt Reese is in town. Hey Matt, how you doing?
Good to see you, buddy.
I know Matt for like 20 years. He was in my wedding, and Matt gets himself into all these cool things, and now he's been selling these high-speed cameras from iX Camera. And this particular model, Matt, how many frames per second can it record?
Up to 1 million.
Up to 1 million frames per second. The kind of image I guess you get out of 1 million is not quite
things that
there.
are going boom and and looking for electric sparks, arcs, stuff like that.
Right, so smaller image strips. We're going to talk about how these cameras work in this video because we've often seen so many videos with the footage from these cameras, but not actually one in operation. Like, how do you set it up? What are all the settings? We're going to kind of dive into this, kind of like how we review things on the channel. Now, I should mention that typically we look at affordable consumer-grade items here. This one is like kind of in Tesla territory, so you could buy a nice luxury car or you can buy this camera. Who uses these cameras, Matt?
All over, so defense, military, to universities and research labs, automotive, so crash test simulations, stuff like that. So
you want to see, I guess if you're engineering something, you want to see how it works. You can slow time down.
When you want to see the unseen, something's happening too quick for you to see with your naked eye, or at 60 frames a second, with a normal consumer camera.
Right.
That's when we bring these in.
So let's step through this camera. The first thing that I noticed on it here is that we have a regular Nikon lens. In fact, this is like a Sigma lens that you can buy on Amazon. So this mount is pretty much universal for the lens?
Absolutely. So we come with a variety of mounts. So we can use either, this is a Nikon F mount. We also offer Canon mounts, C mount lenses, whatever the customer wants. We can just replace this front plate here. And set it up for their lens situation. We do prefer the lenses that have the manual aperture control on the back, so you don't have to have software controlling it. You can do it right here on the lens, which makes it nice because you can find a good supply of those lenses out there.
Oh yeah, they're easy to find, and you can buy a used one perhaps. I mean, if you run out of money buying the camera, you can just buy a $20 lens and you're
well, the order lenses were usually pretty good, so that's a nice thing.
That is a good thing. And we need a lot of, that's the reason why we're out on my deck, is that you need a lot of light for this, right?
It does. It's, basically your shutter times, 1/30th of a second when you're dealing with 30 frame a second kind of shots on a regular camera. Here we start measuring our shots and our shutter times in nanoseconds, right? So in milliseconds, depending on how many frames we're doing. So when you got something moving fast, you want to stop that motion blur. And so even if you have, a high frame rate, sometimes you still need an even shorter shutter time. So, 10,000 frames a second, instead of having 1/10,000th of a second for the shutter time, you might still have the object blurred in that 1/10,000th of a second. So you might go ×2 shutter, so it's equivalent to 20,000, so 1/20,000th of a second, so that's less blur on the object in each frame.
So you're taking multiple that quickly, and you need a lot of light for that. Absolutely.
With that short of a shutter time, there's not much light hitting the sensor with just regular light. Sunlight's always
ideal.
Great. It's ideal. Lots of light kits out there, though, and most of the lights are LED nowadays. So.
And we found down in my studio, I had those cheap overhead lights. They were flashing because they cycle, right?
Yeah,
so you need special
usually
lights
like a 50% duty cycle in those or whatever for the LEDs, so they don't get too hot and they just run. So you don't see it, you and I, it's pulsing too quick, but to a camera that's shooting at thousands of frames a second, you're watching it. You're watching it on and off, and sometimes it's like an eternity of darkness. At the high frame rates, it's like, did they turn the lights off in the room, and then eventually it'll come back on. That's just how fast we're shooting.
Right. So you need really specialty lights, specialty camera, off-the-shelf lens. So that's
there you go.
kind of a good thing. So you're good to go there. So let's take a look at the back of the camera here. There's a bunch of stuff to look at. It doesn't look all that different than my consumer camera. We've got SDI out, so you can actually get video directly out of the camera.
Correct.
And we should also mention that when you're shooting on this camera, it's actually recording onto DDR4 RAM.
Right.
How much RAM is in this camera?
So this particular one's got 144 gigs.
144 gigabytes, not gigabits, not megabytes.
144 gigabytes of DDR RAM in it. And that's the volatile memory that it's storing the shot in real time, because we can't write to a drive fast enough when we're shooting at these frame rates. So it's stored in RAM. And then from there, you don't usually save the entire buffer. You'll go in and you'll trim out and you'll say, hey, I want this section and this section of my shot. You mark it, and you just save that part out. And when you save it, you can save it to either, we have a XSSD hard drive here that just pops out, and little card reader.
Little terabyte
you can put it on your
solid
computer.
state. Looks like a little PC card from my old laptop, right?
So we can save it out right to the XSSD. We can have an internal drive that's non-removable in the camera, which is for our defense customers because for security reasons, they can't have an SSD that can just float off with classified footage on it.
Find its way back to the enemy, right?
Exactly. So they keep all that, we keep that in the camera. Or you can save it right off the Ethernet jack here to your laptop PC that's controlling it.
Or USB there too?
Yeah, we have a USB. So if you wanted a quick shot, you just want to save off to a thumb drive or something, plug it in, it'll pop up in the interface and say, yep, save it to there. Obviously, the XSSD is your fastest interface. So.
And you mentioned that some of your YouTube customers actually just use the HDMI because you can just stream it out of RAM and just get it that way.
So when we're doing the playback on the camera, just reviewing the footage, you know, it's outputting this HDMI or the SDI out, and you can run it right into like a DVR device. And so while it's playing it back, you can just record it right there, like you're capturing it live over the air, and then save that. And that just saves instead of saving the shot to the internal hard drive, which again, depending on the size, you know, the video file sizes can be 4 or 5 gigs, or they can be 40, 50 gigs.
Okay.
You know, the
it compresses it and does all the processing.
Yeah, there's compressing and uncompressing.
Yeah.
So it takes some time to save those and transfer them down to the hard drive. So just playing it back though in real time, no problem. You can capture it at the resolution you need.
You get what you need, or you could output the file and kind of go from there. Now this camera is black and white, but you have color versions available, which probably costs a little bit more, right?
A little bit. There's a slight upcharge on it. It's just, you know, the color filters over the sensor. All the sensors behind the scenes are black and white, right?
Just no matter what color sensors you put in front. And I'm guessing for defense customers, they probably don't want color all the time because they're trying to see a specific.
Most scientific technical imaging is done with the mono cameras. They're also more light sensitive because you don't have the color filters over the sensor absorbing some of the light. So we can get, you know, much better light sensitivity values.
Now another thing that was cool about this camera is that it has a battery on board.
Correct.
And you might need that because if you're doing what?
Well, sometimes if you're out, you want to shoot untethered, you know, and not have to have power next to you. But more importantly for our customers, we have the battery on board. You get about an hour of shooting, by the way, on that battery, so you can be untethered for an hour and.
So it's better than some of my cameras, actually.
Yeah, exactly.
It's better than my little GoPro thing.
better than my old iPhone that went dead in about 45 minutes.
So an hour shooting.
So you get an hour shooting. But the main reason that's important is that we talked about the shot's stored in RAM initially when you capture it, and at that point, if you lose power, you've lost the shot if you haven't saved it yet. And so, if picture you're on you're doing an expensive missile test. You know,
my $5 million missile fires, and it blows up the power generator.
Yeah, exactly. You captured it. So I mean, and anything happens. People trip over power cords. They didn't save it. And I've been at a test where one of the other competitors' cameras were there. We were all doing a shootout, and the guy didn't save it off before they hit the power on a power strip, and he lost the shot.
Right. It's almost like a built-in UPS on it.
Absolutely. So it runs on the battery. It instantly switches. There's no changeover or anything. So you won't lose your shot if somebody pulled the power on it.
And it's pretty heavy duty. It's all metal, so it's designed to be used outdoors.
It is rugged. We have a ruggedized range version of this camera that's got the on the backside here. Got a 500 micron dust filter on it. So I used that. I was out in the desert out in Mojave launching high-powered amateur rockets. And I say it's a 20-foot tall rocket. We were working on a space shot. It's dusty out there. When you're out in the desert, it gets in Black Rock. It gets pretty dusty, and the filter does a great job of keeping everything clean inside.
Now, before we fire this up and start playing around with it, we've been talking a lot on this channel about FPGAs, which we've been using them to play retro video games, right? But those same chips are inside of this camera.
Absolutely. So you can imagine that you need a lot of data buses to, read that sensor data off. So we quadrant up the sensor on this camera. So it's in 4 quadrants, and there's flex cables coming off of that to each of the boards. So we have the video memory boards in there, and those have the FPGAs on them, and that's what's processing the information, reading that quadrant line by line. So as it shifts down and reads the row of pixels out, it's chewing those up, and it's doing that in real time. As it's at 10,000 frames a second, it's a
massively parallel task, which is perfect for an FPGA chip.
Absolutely.
And what's funny is you could probably make this run Nintendo games too if you wanted to, right?
It runs Windows, if you need it.
Oh, it's actually a Windows computer.
It's Windows embedded, but absolutely. So yeah, you could get it to probably do all kinds of fun stuff. Cool.
All right, let's get this thing going. We're outside for the light and beautiful day, so let's make some water balloons.
Absolutely.
All right, let's have at it. All right, we have Jake here with the water balloon. He's our willing participant. We promise you won't get too wet, Jake. Matt, let's describe the process here as to what we're going to do.
All right, so we added a few more cables to the camera here, and so we can see we added a just to our BNC port here, just a little pickle switch it's called. Okay. That's just to trigger it when we want to start the recording. These record in a loop, and it's always overriding that loop, and then if wherever you trigger it, you can catch either from, I have it set to 50% right now, so it's going to take, a few seconds before and a few seconds after for the buffer, right? It's half the buffer.
Now, if I'm firing off a missile, though, I could trigger this some other way, right?
Right. You can interface this to other, laser trip brake wire or brake screen type trigger device, or input, and it'll fire it that way, or you can sync it to an external trigger of any sort. Really, this is just a switch closure.
And so you push that, and then you got to make sure you get it in the right frame.
Right.
Now, what are we recording at right now? What are we going to see?
So right now we are at almost 8,000 frames a second. So
at what resolution?
We are at 1920 by 1080. So
okay,
full
so 1080p,
HD.
and so this is kind of a good first starting point, and then we'll dive into the settings after that and see what happens. All right, so let me get my other camera out. We'll compare the iPhone to the expensive camera.
All right.
And we'll start off and see how it goes. And Jake, we'll get you a towel. All right, so I've got my iPhone out here. Matt has the trigger. So what you're going to do is push that when he pops the balloon. Is that how we're going to do it?
Well, I'm going to go into the record loop now. So it's filling the memory buffer.
Okay.
We've got 6.1 seconds of record time at this frame rate and speed.
Oh, so we'll definitely catch this.
Oh, we're going to catch it, no problem.
Okay.
And so I'm just letting it fill the buffer. Now that the lights go green there at the top that are blinking, we're ready to go.
All right, so go ahead.
So whenever he wants to give it a go, I think we've got this.
All right, let's take a look. Go ahead. And we're going to get out the pin.
Ready?
Yep. All right.
That was a lot of water.
Let's see how much we got.
Okay, so we've got Matt's computer here, and we have the image now. Is it downloaded into this?
Nope.
Oh, so this is off of RAM right now.
It's all for RAM right now. It's playing back in the frame buffer on the camera.
Okay.
So we can go ahead and scroll through this, and we captured, the buffer was 6.1 seconds of physical time.
Right.
But in that amount of time, we captured a whole lot of frames. All right, so right now, it's playing back.
It's going to take a while to get to when he actually pushes the pin in there.
I'm going to just drag this and pull it.
Okay, so here we go with the pin. And now we're going to play back.
And I push the button right in the middle here at the 50%.
Okay. Oh, look at that. Okay.
And so we go back.
Back a little bit. Look at that. All right. And hit play. So
it's playing, yep.
Oh, is it playing right now?
Yeah.
Oh, wow, that's how slow it's going.
Oh, yeah.
And this was how many frames per second?
This was 7,960.
That is really cool. Now, what we saw was just the water dropping like a rock.
And your iPhone will show a little bit of this, but keep in mind, you were at 240 frames a second on that,
right?
And we're at almost 8,000.
So that's a big difference there. Look at that. That is awesome. Just one big blob of water.
Yep, falling away.
And we heard it just go.
Absolutely, no, it's amazing. And we didn't see that when we watched it, did we?
No, we didn't. And definitely not on the iPhone. And it's funny too when we look at the footage from our camera, the one that Jake is shooting with right now. It's just plop and blop, and that was it. Yeah.
Exactly. So
it keeps going.
Oh yeah, so we can speed up the playback rate, play it back at 30 frames a second or something, but you see it's just.
And then we can choose from here how we want to output that file.
Right, exactly. Yeah. So, if we're recording the screen here, we could say, hey, I want to come back here, and I'm going to mark, say, right there is my in point.
Okay, so this is just like any other piece of editing software.
Right, exactly. So I'll say I'm going to use current there, and then I can hit play. Get it one more time because it's just that cool to see.
That is so cool. Yeah, that is neat. And then of course we could go higher if we go down to a lower frame rate.
Yeah, lower resolution.
Yeah.
Lower resolution, we can go higher frame rates.
And what do you think we would see differently if we went to a higher frame rate?
You might see I think if we zoomed in tight, because we're actually not seeing this at the native resolution right now, because this whole laptop screen is 1920 by 1080, and we're cutting it in. So if we went to 1:1, we might start to see, if we went frame to frame, a little bit of blur on the edges of the balloon, because when the balloon retracts, it's really fast.
Okay. Even with that high speed.
Yeah, it's a fast thing. So you might see a little bit of motion blur on the tip of the balloon as the edge is retracting. So we might need to go a little higher shutter speed or a higher frame rate if we were trying to resolve that issue. So now we've got everything, basically the end of the action here. We'll pause that and we'll say, okay, we're going to mark our output there.
Okay, good.
And once we've got that set, we can play it and loop it. We can get our histograms and check our levels and all that.
And then we can go ahead and export it.
Yeah, but we can export it. We can also do some measurements here. And so if I wanted to measure, you know, how long it took for the edge of the balloon to go from here to here, if we had something in the frame that we could scale on, it would calculate, tell us the speed.
You could set a marker to say how fast that thing
We could see how fast that edge of the balloon was moving.
And I guess that's why sometimes they shoot with that checkerboard pattern behind it, so you can use that as a reference point.
As a calibration reference point.
Yeah.
And if we're done measuring it for now or whatever, we can go into our save mode, and we can say, all right, we want to save it to the computer or we save it to the camera. We'll save to the camera.
Right, and we'll pull it off later.
Yeah, and that's good.
Give me a video file so I can import it. So let's say AVI, which I can then convert to something.
And we'll do we can do an uncompressed or compressed. We'll do a compressed one. It's a little, it still looks great.
How long does it take to export this when you do it?
Well, it all depends on how many frames you picked.
Okay.
So right now we are saving a total of 3,484 frames.
Okay. That's not too bad.
No,
and that's all happening inside the camera right now.
Right now, that's saving to the SSD in the camera.
Well, that was cool, right? So now we're going to do some other stuff because there's a lot of configuration that you can do on here, and Matt's going to guide us through a few of these things. They have two interfaces. One is a computer interface. The other one is a tablet that you can bring out in the field with you. But Matt says there are more settings in the computer version, right? That's what we are looking at here.
You told me your viewers are kind of nerds and wanted to see the good stuff.
That's it.
We're going to get into this and show you all the stuff.
So my request of Matt here is to go in and give me as much frame rate as I can get with a full image. And so we need to reduce our resolution to get there.
Right.
So we were at 1080p with that balloon pop, which looked great. But we're going to go down to 480p now.
Yep.
And what will that mean for our frame rate?
So with 480p, we should be up right around 50,000 frames a second or so.
Okay.
We'll see. Well, it'll tell us what we can do with that.
Okay.
So, first thing we're going to want to do here is on this panel on the right. Right now we're in resolution priority mode. So it's telling us what the fastest resolution that we can do. Fastest speed we can do at this resolution, and right now that's 7960. What you saw there,
right?
So
that's at 1080p.
That's at 1080p, right?
So if we
and
go
that's
down,
not the full sensor, by the way. The full sensor is actually 2048 by 1536. So it goes a little better than HD even. So we'll get some shots with that later too.
But not 4K.
But not 4K. No, it not much. Can't get much frame rate at 4K.
Right. And your clients don't necessarily need that resolution. It's more about seeing what's happening,
It's seeing what's happening.
Measuring distances.
You can get better lenses and get in tighter, and you can get the same pixels, amount of pixels to measure by. So, so we have a bunch of standard resolutions. You're requesting 640 by 480. That goes back away. So we'll go into manual mode.
I want
here.
DVD resolution.
Yeah,
Matthew.
we're going to go manual mode here, and we'll just type that in 640
by 480.
By 480, and we're going to hit set.
And that'll give you some new frame rates you can choose from.
Right, and now if I go back up to my frame rate here, I can look, and you can see it goes all the way up to
48,000.
Yeah, 543, I believe.
Okay, so if we select that, how much time can we record now?
So it's still about the same. If we're at the max speed for a given resolution, the limiting factors are data rate for how quickly we can save. So this is the 726, so we can do 26 gigapixels per second to save, right? So that's going to always come out to about 6 seconds if you're at the max resolution and max frame rate for that resolution.
Right. So we'll have about the same amount of time to play with.
6.5 seconds that we can save off at this setting here. And you can see the screen got real dark there. We're going to need to open up some.
That's the issue with the light we talked about.
Exactly.
Okay, so now that we're at a higher frame rate, we need more light.
Right. Right now our shutter time is 148,643 of a second. Okay. So it's a pretty short time duration, and we'll open up the aperture on the lens a bit, and also we'll maybe hit a little bit of gain here to get some lighting. But
and then if I adjusted how much of because there was one area where you could actually adjust how much of the frame you're capturing. So if you reduce that frame capture area, make it narrower.
Well, that's what we're doing with the resolution.
Okay,
right? When we're setting
thing.
that resolution, we're reducing what we're capturing in the frame.
So it's able to look at a smaller portion of the sensor and then therefore read it faster.
Exactly. You're reading off less rows and less columns of the sensor, so it can go at a faster rate. So here our settings are pretty much set here. We're going to need to go ahead and we'll
do some more calibration.
Do a quick calibration on it, and we'll open up the lens a bit too, real quick while we're at it. So let's go ahead and hit that.
All right. So let's go over here to see what Matt's doing on the lens. So Again, we've got our off-the-shelf lens on this thing, so you're going to put that back on.
Actually, I think I've got a lens cap for this one.
Okay.
1 second.
And then the calibration you do with the lens cap on, right? Just to get that.
Yeah, we just want to get a good black reference. So you can either put a body cap on, or
and that'll tell. So many cameras want a white balance. This one needs a black balance.
Right. You just want to make sure that you. Excuse me. Sorry about that. You just want to make sure that you don't have any sensor noise. And this just looks at what the noise levels are in the sensor when there's no light hitting anything.
Okay, right.
Where the levels on the chips, and that kind of resets the floor for the noise.
All right, so he's going to do that real quick.
It's got that. We're done.
All right, so now we can put the lens back on, and why don't you just show them what you're going to set on the lens too, because you know, this is again no auto anything, but again an off-the-shelf Nikon lens. We're going to adjust the aperture.
Right, so this is the aperture ring here, and so this is a fast lens. It's a 50mm 1.4, and so 1.4 we're wide open. Got plenty of light in, as you can see on the screen here. It's
all white,
but no depth of field. So as we, stop that down a little bit.
And so by stopping it down, you're putting you're increasing the aperture level. So
well, by stopping it down, we're making the hole smaller.
Right. So you're letting in less light.
We're letting in less light, which is giving us more depth of field.
Right. And the challenge is that when you're letting in more light, it also makes it more difficult to focus.
Right. Yeah. Your depth of field gets really narrow. It can get razor thin. If you're wide open, it's razor thin, and so you move too much either way, and
you got to really calibrate here. So Matt, how many frames per second again?
So right now we're at 48,000 and change.
48,000 and change. All right, Jake. On ready, Matt?
Start recording now. It's filling the buffer, so we're good whenever you are.
All right. So 3, 2, 1, and pop it. I think it went the same way as it did before. Did you get wet that time?
A little bit. A little bit of the splash action, but it's not too bad.
Let's take a look now and see how it came out. So we'll have Ellie take a look with us too.
Yeah.
All right. So there comes the pin, and we just got to get it to the right spot there. Oh, okay.
Okay. So now we're gonna hit play. Notice it's taken a while.
So it's almost like his hand's not moving here. It's really that slow. Wow. And that's because we're at a significantly higher frame rate now than we were before.
So we can
scrub
a little faster.
or we can play back at maybe 30 frames per second. So let's do that.
We'll bump that up.
All right.
And we'll just reverse it when we see it pop, and then come back in.
Come back in.
It's almost
you can't even see his hand moving.
No, it's
really slow. And this is at 480p.
This is at 480p, right? And we'll go a little faster again.
All right. We'll go up to 60 maybe just to make it happen a little faster.
Yeah. Okay.
Whoa, look at that. That is significantly better than what we had before.
Oh, absolutely. So we'll go drop this back down to 15 or so.
All right, just to get a better feel for it. Yeah.
And look at that tear.
Wow.
So you talked about what you see now that you didn't see before. See the ripple on the leading edge?
You can actually see the impact of, like there's almost an equator there that the pin made an impact on. That is wild.
So let's go back and mark that endpoint. I don't know if I did or not. Let's just go mark that real quick.
Yeah, then we can export that and we'll play it back for the viewers. Now the resolution won't be there, but the frame rate certainly will be.
Absolutely.
And now you're going backwards? It looks even cooler backwards, actually. Cool.
Okay, so let's mark it. Use that. We'll play it forward one more time for giggles here.
What do you think, Ellie? Is that cool?
That's a balloon popping.
Look at that.
And still retracting the balloon around. It's not even left yet. And the water's all just hanging there.
Right, it's hanging there. And as we saw in real time, it kind of just drops like a rock, but it really suspends itself. It's funny how obviously gravity's impacting it all the time, but it almost feels like gravity grabs a hold of it and then pulls it down.
It's just frozen in time there.
Yeah. That is really cool.
Let's go a little faster here. Try and make that go away. And it helps when you're playing these, when you're editing these and playing them back. You know, a lot of times you speed up the playback after the fast actions occurred so that you can still show everything.
Right.
But get to the...
It looks like a pool of water suspended in the air. It's just so cool. You can even see how it's reflecting on his hand as it's going down. That is awesome. And then it just drops like a big blob of water.
Exactly. It's like a giant droplet.
Yeah, very cool.
We'll let that all fall out of the way and we'll stop it and save that off.
All right, cool. So Matt, what are we doing now?
I think we're going to make a mess on your deck here is what we're going to do.
With what?
So we got a little foam paintbrush with some paint on it. We're going to put the paint on it. And just Just want to hit that with the pellet and watch the paint splatter.
And I notice here that you have some lights now on this, and why is that?
Yeah, we have some little LED lights here just to give it some additional lighting. We're starting to lose a little bit of sun, and we're also going to go that much higher in frame rate. So,
and we're going to shoot it with a pellet gun, not a firearm here, right?
Yeah, that's a pellet rifle, and yeah, but it's still got some speed behind it, so we want to make sure we have a backstop and use good safety procedures. But just want to get some extra light so that we can shorten that shutter time up and make sure there's no blur on the pellet.
So Matt, we did a test shot of the pellet
right
going into the paintbrush, and you wanted to show me something in relation to frame rate and shutter speed.
Yeah, absolutely. So before we made a mess with the paint and got it everywhere, we figured we'd get some good test shots in here. So as we watch this pellet come in, it'll pause here 1 second.
Yeah.
There we go.
It's crazy how fast. And this is on a high-speed camera that it's coming in. That's right.
So we're shooting at 5,300 frames a second here.
Right. And you caught the pellet, but you could barely see it. It's a big streak.
Exactly.
Right?
So the pellet's a streak within a single frame. That means it's a shutter time that's allowing that. So it's moving that distance that you see here on the screen within the time the shutter was open or capturing for that frame. If I jump to the next frame, and you watch the distance it traveled from one frame to the next, that's more controlled by your frame rate.
Ah, okay.
So right now, we're using a ×3 shutter, so we have a frame rate of 5315, but we have a shutter time equivalent of about 15,000 frames a second, 15,900. So in this case, we're going to probably want to go up a bit in our, at least go up in our shutter to try and remove that blur there. But we're probably also going to go up in our frame rate a little bit as well to get some more detail of the impact when the paint splatters and stuff.
So there's a lot of things to consider here. It's the aperture, it's the shutter speed, it's the frame rate.
Well, and it's the resolution, right? So right now we're at our max resolution, which is 2048 by 1536. And I can go up in frame rate, but then I do start to lose resolution and have to stop down on my resolution a bit. However, I can go up in shutter time as high as I want without giving up resolution.
Right, but you need more light.
But you need more light, exactly. We need more light for more frame rate too.
Right.
Because obviously your frame rate's dependent on, you can't go longer frame rate than the shutter.
So those lights will help with that.
Longer shutter time than the frame rate there.
Yeah.
So let's give it another shot. Let's see what we can do.
So Matt, how do we set up the camera now?
All right, so based on what we saw in our tests there, I decided we better go up in frame rate and shutter time quite a bit. So we're at 30,000 frames a second for our frame rate, and we're at a ×2 shutter. So our shutter is equivalent to 60,000 frames a second. And that should dramatically remove the blur we saw, because before we had a shutter time of about 15,000, so gone up about 4 times. That blur should be 4 times smaller now. And
we got some paint on the brush here now.
So I think we're going to make a mess this time.
Right, and we got the lights going here. These lights have very noisy fans on them. They're pretty warm too. These are LED lights, and there is our subject. And we got the pellet gun here ready to go. So I think I'll let you fire it off so I don't shoot out a window or something. And we'll see how this does.
3, 2, 1. But I think our frame rate was going to be pretty good. This should be pretty slow. Look nice. Oh, look at all the stuff flying off of it.
Yeah, that's the paint and the foam coming off, it looks like. It's kind of fun watching these things in reverse.
The pellet ricochet, this is pretty good.
So we'll be able to see the pellet come in. Look at that. Wow.
Wet and low.
Yeah. So I think your aim was a little bit off there,
Yeah, it's sighted in a little farther away than
So we're hoping to get a little bit more paint splatters. Maybe you want to put some more paint on there.
Pellet ricocheting there.
Yeah.
Gosh, put those goggles on, or safety glasses on.
Very cool.
Yeah, so we'll speed this up.
See one more shot.
Yeah.
All right.
All right, so I think we definitely got something good on that one. Let's just take a look. See what caused all that splatter.
Nobody got shot here, so we're good.
Yeah, we'll scrub through this. Oh, there we go. Let's rewind it. So epic watching it.
Whoa, look at that one. That is great. And you got the pellet coming in and everything too.
Yeah. So we'll pause it there. Let's mark our end point. Yeah. Play back at 30. I turned up the shutter a little bit here. I'm a 3-time shutter now, so we're 90,000 frame a second shutter.
Whoa. You can see like the air hit it before the pellet even arrives there, right? Look at that.
I kind of cheated. There's the edge of the barrel there.
Oh, I see.
I didn't want to miss.
So the air is a little faster than the pellet.
in this case.
Yeah.
Oh, the surface
That's awesome.
deformation on the paint was incredible.
That is amazing. That's probably the best thing we've done so far today.
That's beautiful.
Well, Matt, I want to thank you for bringing over your toys here. This is pretty cool. Now, this is like the top of the line camera, right?
This is. Yeah, it's the 7 Series.
And there's now, just like BMW, there's a 5 Series?
There is a 5 Series
okay.
like the BMW.
Yep.
So comes in a little bit lower price point than the 7 Series. Still full HD resolution. So
just lower frame rates.
A little bit lower frame rate, a little data throughput rate, but no battery, so it's a little more portable. It's a smaller camera.
Right. And I found it was, you know, it's funny, the interface is very easy to understand. You know, if you've used the consumer camera, there's a lot of similarity with that.
Absolutely. Just frame rates are higher.
Frame rates are higher, and I think they're, you know, the shutter speed was also interesting because that silly string we were playing with, we saw a very big difference in the sharpness of the string as it was coming out.
Right.
Because the frame rate was the same, but the shutter speed on the camera was changed.
Yeah, we tripled the shutter speed and kept the frame rate the same, so each frame was a lot sharper.
Right, each time you did it. So you can really tweak a lot with this to get it to where you want to be. What are some of the coolest things that you have captured on one of these?
Definitely out in the desert playing with explosives and C4 and stuff. So it's hard to beat that.
Yeah, we can't do that here.
It's a little more limiting here, but that's some of my favorites up the Schlieren imaging we've done. So I worked with another YouTuber, Backyard Scientist.
Okay, yep.
And he had a bet with somebody about making a supersonic Nerf dart.
Okay.
And we did it. We cheated, and we wanted to prove that we did it. So we use Schlieren imaging, which lets you kind of see the shock waves and the patterns in the air. And so we fired it past the mirror, and you could see the shock wave on it. And that's
Wow.
we had to use the 7 Series to
Very
capture
cool.
that.
We'll have to link to that video so people
Absolutely,
can check it
yeah.
out. So there's a lot you can do with these things. We were just doing some backyard experiments with it, and nobody got hurt, which was good. That confetti
Absolutely.
was a little more than I expected, but
It caught us all off guard. I
yeah,
think,
that was a pretty big bang. But other than that, it was pretty cool. So very good. Well, I just want to thank you for bringing this over.
Yeah,
This is something
thank
that
you.
goes well beyond sometimes what we usually look at. And I've seen so much of this high-speed footage, but I never see how it works. So it's fun to
Right.
just get in there and play around and adjust some of the settings and see how you can get everything
It's
going.
definitely fun, and if you've got something, a shoot coming up, you want to do something fun, let us know. We're headquartered right up there in Boston, so down the road from you, and love to get a 5 Series down here, something that you play with again.
Cool, it'd be fun to play around with. And that'll do it for this video. I want to thank Matt again for coming down, and we'll probably see him again in the future. And until next time, this is Lon.TV. Thanks for watching.
This channel is brought to you by the Lon.TV supporters, including gold level supporters, the 4 Guys with Quarters podcast, Tom Albrecht, and Kalyan Kumar. If you want to help the channel, you can by contributing as little as $1 a month. Head over to lon.tv/support to learn more. And don't forget to subscribe. Visit lon.tv/s.